straight line graphs. We're trying to find the equation of this line which goes from minus 1, 1 and also through the point 3, 9. Well, you need to learn certain formulae if you don't know them already. The first one is that the gradient equals the increase in y divided by the increase in x. And so the increase in y, that's going from 1 up to 9. The increase in x is from minus 1 to 3. So we do 9 take away 1 and 3 take away minus 1. So that's coming to 8. 3 minus minus 1 is 3 plus 1, which is 4. And that's the 8 for the increase in y and 4 going across there for the increase in x. Obviously 8 divided by 4 is 2. So in this case the gradient is 2. Y-intercept. Well, the y-intercept is where it cuts the y-axis here, and that is equal to 3. So y-intercept is 3. And so if we were using y equals mx plus c as our equation, we would say that y is equal to 2x plus 3. Gradient 2 is m, and the y-intercept c is 3. However, there's another equation which is often more useful, and that is y minus y1 equals mx minus x1. Now this is the equation of a line which has gradient m again, but which goes through a point x1, y1. Now in this case, because I've drawn it out for you, you could see that the y-intercept was 3, so it was easier to use y equals mx plus c. But usually you will be given 2 points and you're not actually told where it's going to cut either axis, and so this one would be easier to use. Now if we used this one and we use the point 3, 9, then y1 will be 9, x1 will be 3, y minus y1, y minus 9, the gradient is still 2, and x minus 3. If we use the other point, minus 1, 1, x1 is minus 1, y1 is 1, so you can do y minus 1 equals 2, but then you're doing x minus minus 1, which should rewrite as x plus 1, because a minus times a minus is a plus. So either of those two could be written as equations of a line instead of writing this. Now, you may say, well, it looks like we've got 3 equations here, but are all different. But if we actually expanded these ones at the bottom, you'll find that they are the same as this equation. So for instance here, 2x minus 6, and then if you move the minus 9 across, it becomes plus 9, so you get 2x minus 6 plus 9, which is 2x plus 3. For this one, 2x plus 2, move a minus 1 across, it becomes plus 1, and you get 2x plus 2 plus 1 becomes 2x plus 3. So all these are the same as each other, and in most questions it doesn't matter which one you actually write down. And so if you're given these points here and you're not told the intercept, it is usually better to write this down and just leave your answer like this, or write this one down, leave the answer like this, because if you do further work, not only does it take time, but also if you then make a mistake, that can cost you marks. Now the other thing that you may want to do is you may want to be doing some graph sketching, and so in order to do that we would not only need to know the y-intercept but also the x-intercept. Now here you can probably guess what it is, but in order to work it out, what we use is this. For my y-intercept is where x is 0. And if I look at this equation, if I put x equals 0 here, I am left with y equals 3. If I put x equals 0 in one of these others, it will still work. So if I put x equals 0 there, I will get y minus 9 equals 2 lots of 0 minus 3. So it's 2 lots of minus 3 minus 6. Minus 6 add 9 plus 3. So it's still going to work. It will work for the other one as well. So the x-intercept is where the y coordinates are 0. So for the y-intercept we put x equals 0. For the x-intercept we put y equals 0. And so you put y equals 0 in any of these equations. And I'll do it in this one because it's the easiest to use. We've got 0 equals 2 lots of x plus 3. So 2x will be minus 3. X will be minus 3 over 2. So you get minus 3 over 2 there, and so we could actually label that there's our x-intercept at minus 3 over 2. So the important things to have learnt: the gradient is the increase in y divided by the increase in x. You've got two types of equation, y equals mx plus c, or y minus y1 equals mx minus x1. Y equals mx plus c is great if you know the y-intercept, but if you just know a point or a couple of points that the line goes through, you might find that this one is a little bit quicker. It's often the quicker one to use. If you want to sketch the line, then you will need to know both intercepts. To find the y-intercept, you put x equals 0 and work out y. To find the x-intercept, you put the y equals to 0 and work out x. Right, let's try some questions. First, find the equation of a line through the points 4, 7 and minus 2, 10. You notice this time we haven't got the graph drawn. So we use the equation. In the gradient m is the increase in y divided by the increase in x. Now it doesn't matter which way round I do the coordinates, but I'm going to do 10 minus 7 minus 2 minus 4. I could have done instead 7 minus 10 on the top, 4 minus minus 2 on the bottom. It doesn't matter which way I do it, but I've got to be consistent. If I do 10 minus 7, I must do minus 2, take away the 4. So I've got to keep it the same way round. 10 minus 7, 3. Minus 2, take away another 4 is minus 6. 3 divided by minus 6, well, 3 over 6 cancels to a half, so with a minus sign there, it's minus a half is my gradient. Next part, I'm going to use y minus y1 equals mx minus x1 because I don't know where it's cutting the y-axis. So y minus, well, my y1, I can use either point. I'm going to use the point where they're both positive numbers because it's easier. So y minus 7 equals gradient minus a half x minus 4. It gives you the answer straight away. We don't need to do any more work to it at all. That's our answer. We could do more work, but it's not necessary. Next, sketch a line. Now you'll notice this line's written down a different way. Instead of writing it as a y equals, I've got it written as 3x plus 5y equals 30, but it still gives us a straight line. To do this, we need to find our intercept. So whenever you sketch a line, you're going to show the x-intercept and the y-intercept. So when x is 0, what we do is find y. Well, if the x bit is 0, that goes to 0. You're left with 5y is 30, so y is 6. So when x is 0, the y coordinate is 6. That's my y-intercept. Now the x-intercept. That means I put y as 0. That goes to 0. I'm left with 3x is 30, so x is 10. So when x is 10, y is 0. When x is 0, y is 6. That means my sketch will have when x is 10, y is 0, the x-intercept, y-intercept is 6. And notice, besides labeling this, it's a good idea to write down the equation of the line so that we can see exactly what line we're talking about. So whenever you're drawing a straight line, then always, if you're drawing a sketch, you need to show the two intercepts where it intersects the axes. Next one, question 3. Write the equation of a line through minus 3 minus 2 and 4 minus 6, and we're writing it now in a different form. In the form ax plus by plus c equals 0, where a, b and c are integers. Now integers are going to be whole numbers, but they could be positive or negative. Also, of course, you can have 0, but you're not allowed any fractions. So, then the next part of the question is sketch the graph. Well, we handle it the same way as before. First, we find the line using the gradient is the increase in y divided by the increase in x. So it doesn't matter which way round I do these. I've done minus 6 take away minus 2, and then 4 take away minus 3. I could have done minus 2 take away minus 6, minus 3 take away 4. I will get the same gradient. Let's do it my way. Minus 6 take away minus 2. Minus minus becomes a plus, and the minus minus there becomes a plus. So I'm left with minus 6 plus 2, 4 plus 3. Minus 6 plus 2 is minus 4. 4 plus 3 is 7. So it's minus 4 over 7. That's my gradient. Next bit, y minus y1 equals mx minus x1. It doesn't matter which of these two ones I'm using as my x1, y1. I can have x1 as minus 3, y1 as minus 2, or x1 as 1, y1 as minus 6. I'm going to choose this one because at least one of the values is positive. So y minus minus 6, that's y plus 6, equals the gradient, minus 4/7, x minus 4. That's one way of writing the equation. I could have written it using those points instead. Now I need to be able to get it into this form. So I've got to get rid of fractions. So what I'll do is I'll multiply by that 7 and then I'm going to expand it. So let's do a times by 7. When I multiply the left-hand side by 7, I get 7y plus 42. Then that means that that 7 now has disappeared from the right-hand side, and I'm left with minus 4 lots of x minus 4. So I've done the multiply by 7. Now I'm going to expand. Minus 4 times x is minus 4x, but now be careful, it's minus 4 times another minus 4. Minus times a minus, a plus, so it's minus 4x, minus 4 times minus 4, plus 16. Next stage, we want everything on one side equals 0. So I'm going to move everything to the left-hand side. So when I do that, that minus 4x moves across, becomes plus 4x, the plus 16 becomes minus 16. These stay the same. And now just simplify. I've got 4x add 7y, or 7y add 4x, doesn't matter which way round I have those. 42 take away 16 is 26. So I've now got it in the right form. Notice I've got number of x, number of y, and number on its own equals 0. And all these numbers, 4, 7, and 26, are all integers. Now, there are other answers I could have here. I could have minus 4x, minus 7y, minus 26 equals 0. That would still be correct. They'd still all be integers. Or I could have 8x plus 14y plus 52 equals 0. Still all integers, just doubling everything. But what I can't have is any fractions involved. I can't have things like 2x plus 7 over 2y plus 13 equals 0, because with 7 over 2, the 3.5, that would be involving fractions. It wouldn't be an integer. Next stage, sketch the graph. So we need to find the intercepts. To do that, put x equals 0 to find the y-intercept. Well, if x is 0, you get 7y plus 26 is 0, because the x's have disappeared. That means 7y equals minus 26, so y is minus 26 over 7. Y equals 0, 7y will disappear, you're left with 4x plus 26 is 0. Here I'm going to halve it because 2 goes into each number, so I get 2x plus 13 is 0, 2x equals minus 13, x equals minus 13 over 2. I could have written minus 26 over 4, but it's better to have it cancelled down. And then finally the sketch, well, that's where it cuts the x-axis, that's where it cuts the y-axis, and notice that I label both those points, minus 13 over 2 where it cuts the x-axis, minus 26 over 7 where it cuts the y-axis, and the equation of a line is written down next to it as well. Okay.